in the circuit shown in figure, in the circuit shown in the figure, question number A, calculate the equivalent resistance. Calculate the equivalent resistance. Question number B, current in each resistor using Kirchhoff laws. Current in each resistor using Kirchhoff rules. First take down the network. We have E, R1, R2, R3, R1, R2, R3, and then we have another resistor called R4. The values are also given. I'll give you the values. E is 10 volt. R1 is 4 ohm. R2 equal to R3 equal to 15 ohm. R2 is 15 ohm. Similarly, R3 is also 15 ohm. And R4 is 30 ohm. This is the network. Take down this network. First question is calculate the equivalent resistance, and the second one is find out the current through each branch using KVL and KCL. The currents are given as I1, I2, I3, and then I4. I1, I2, I3, I4. So first let us find out equivalent resistance. I'll write solution. Now if you see in the figure, 15 ohm, 30 ohm and another 15 ohm, they are all in parallel. 15 ohm, 30 ohm, 15 ohm, they are all in parallel. So 1 by R equivalent dash is equal to 1 by 15 plus 1 by 30 plus 1 by 15. This will solve this. So if I take 30 as the common denominator, it is 2 plus 1 plus 2 or 5 by 30. R equivalent dash will be equal to 30 by 5, which is equal to 6 ohm. Now R2, R4, R3, this parallel combination 6 ohm. That parallel combination will be in series with 4 ohm. Therefore total equivalent resistance R equivalent will be equal to, this is question number 1 we are doing, total equivalent resistance R equivalent equal to 4 plus R equivalent dash, because 4 ohm and R equivalent dash are in series. 4 plus 6, which is equal to 10 ohm. The answer for first question is the equivalent resistance is 10 ohm. Now we need to find out current in each resistor using Kirchhoff rules. I will just try to write here only so that the figure is also seen. Now before applying, let us mark all the junctions. Let me mark this junction as A, B, C, D. This is I1, I2. So if I apply KCL at this junction, I can write this is I4, I3. So this current will be I3 plus I4. Because at this point this current is entering, the other two currents are leaving. So I3 plus I4 is equal to this current through the branch AD. So at junction A I can write, at node A or junction A, I1 is equal to I2 plus I3 plus I4. Current entering I1 is equal to current leaving. I2 plus I3 plus I4 currents are leaving. I1 equal to I2 plus I3 plus I4. Call this as equation number 1. Now we can apply KVL to different loops and try to find out the currents like I1, I2, I3, I4. Now consider this loop A, D, B. So apply KVL to these loops. Apply Kirchhoff's second law or KVL or loop rule. Consider loop ADB, ADBA. ADBA and go in clockwise direction. We have I4 into 30, that is minus 30 I4, and when we come here we have 15 I2. According to sign convention it is 15 plus 15 I2 equal to 0, or this can be simplified as I4 is 15 by 30 I2, or I4 is I2 by 2. I4 is I2 by 2. Now consider loop BDCB. Consider loop BDCB. We have resistance R3 and R4. 15 I3, that is minus 15 I3, and then we have 30 I4, that will be plus 30 I4. Equal to 0, or I4 is I3 by 2. I4 is also equal to I3 by 2. From this equation, actually, we can say, I2 is I3. We have 4 unknowns, so we need 4 equations. 3 equations are over. Now consider loop A, B, A, B, C, D we have marked, so we will mark A, B, C, D. This one I will mark as E, F. Now consider loop A, B, F, E. Here we have minus 4 I1. We have 4 ohm, 15 ohm, 10 volt. Minus 4 I1 minus 15 I2 plus 10 because E is 10 equal to 0, or this can be simplified as 4 I1 plus 15 I2 equal to 10. I1 plus 15 I2 equal to 10. Equation number 4. Also in mesh or loop ABCD, ABCD, ABCD we have ABCD. So here we'll have minus 15 I2 plus 15 I3 equal to 0. You can write that. Loop ABCD. Minus 15 I2 plus 15 I3 equal to 0. Or this will give us I2 equal to I3. I2 equal to I3. Now we need to solve all these equations. We will first write all the equations whatever we have. We have I4. We got I4 is equal to I3, which is equal to I2 by 2. This is one equation we have. Then we have 4I1 plus 15 I2. I am writing the equations once again. 4I1 plus 15 I2, which is equal to 10. Also we have I1 equal to I2, I1 equal to I2 plus I3 plus I4. Another we have I4 equal to I3. Not I4 is equal to I3. Yes, I4 is equal to I3. Sorry, not I4 equal to I3. We have I4 is equal to, sorry, not this one. This is wrong. I4 is I2 by 2. I4 is I2 by 2. I4 is I2 by 2, and also we got I4 is also equal to I3 by 2. I4 is also equal to I3 by 2. So from these, actually not I4 equal to I3, actually I2 is equal to I3. I2 equal to I3. So if I substitute I2 equal to I3 here, I will get I1 equal to I2, I3 equal to I2. So 2I2 plus I4. 2I2 plus also I4 is I2 by 2. And this will give us, I1 is 5 by 2 I2. I1 is 5 I by 2. Okay, now we have I1 is 5 by 2 I2. We need to solve all these equations, and finally we will get to these values. So if you solve all these equations, we are finally going to get, now you can substitute I1 as 5 by 2 I2 in this equation. So that will give us 4 into 5 by 2 I2 plus 15 I2 equal to 10, or I will get it as I2, which is also equal to I3, will be equal to 2 by 5 amps. I2 equal to I3. You have to solve this equation to get this value. I2, which is also equal to I3, is 2 by 5 amps. Because it is 2 2s are 4, 20 plus 15, that is 25. So 10 by 25 leads to 2, gives us 2 by 5. I2 is I3 is 2 by 5, or I4 is I3 by 2, which is 1 by 5 amps. I2, I3, I4 we got, and finally we will have I1. I1 is 5 by 2 I2. 5 by 2 into 2 by 5. That will give us 1 amps. These are the values: I1, I2 and I4.